I'm gonna talk about all cases in adding integers, but first let us define integer quickly. An integer is a whole number, either positive, negative, or zero, without a fractional part. There are three types of integer. First is positive integers, 1, 2, 3, 4, 5. Second is negative integers. Examples are -1, -2, -3, -4, -5. And the 0, 0. Characteristics. 1. No decimal point. Integers don't have fractional parts. 2. Whole numbers. Includes positive, negative, and 0. Now, let's talk about the first case, the easiest one. Adding two positive integers. Let's say 2 plus 4, of course answer is obvious, it's 6, but let's understand why answer is 6. To do that we use the number line, this is the 0, and let's start with 2. We add 4, so we move to the right 1 2 3 4. With that we can conclude that the answer is 6. We'll use number line in answering all the cases. Let's solve another problem. In case 1 3 plus 4. In number line we start with 3 and move 4 to the right because 4 is positive. Now let us move to case 2 where the second integer is negative. The first problem is 9 plus -6. In this second case where the second integer is negative, which in this problem is 6, we can convert this problem in 9 minus 6. To prove that 9 plus -6 is equal to 9 minus 6, let's look at the number line. Let's start with 9, and because 6 is negative we move 6 to the left 1 2 3 4 5 6, so we got 3, and in 9 to 6 it's obvious that the answer is 3. To sum up, if the first number is positive and the second number is negative, we just copy the number and make it a subtraction. I have a video on subtracting integers. If you're curious, there's a link in the description below. Let's look at another example in case 2. 8 plus -3. In number line we start with 8 moving and move 3 to the left because it's negative, so we got 5, and if you don't want to use the number line to save time we can just convert it into subtraction. 8 minus 3, it's equal to 5. Now let's go to the case 3. In this case the first integer is negative. Here is the problem: -5 plus 3. In number line we start with -5 and move 3 to the right because 3 is positive, so we got -2. We can write -5 plus 3 to 3 minus 5 by using commutative property of addition. I made a video on commutative property of addition and multiplication. There's a video link in the description if you want to know. Let's look in another example. -8 plus 6. By using commutative property of addition we can rewrite that problem into 8 minus 6, and the answer is obviously 2. Now let's have the last case, case 4, adding two negative integers. -6 plus -4. When you add two negative integers the trick is just copy the negative sign and add the integer, which in this case 6 plus 4 is equal to 10, and copy the negative sign. Let's have this problem: -2 plus -3. Again we add the integer 2 plus 3 is equal to 5 and copy the negative sign, so the answer is -5. To prove that the answer is -5, let's look at the number line. Let's start with -2 plus -3, so we move 3 to the left and we are correct. The answer is -5. Bonus problem: what if we have multiple integer? Let's have 6 plus -2 plus 7. In adding multiple integers we have to use the rule order of operations. I have a video on that, link in the description. So according to order of operations we have to solve equation from left to right. So let's start with 6 plus -2 equals 4. We bring down plus 7. 4 plus 7 equals 11. Another example: -6 plus 3 plus -4. First let's solve the equation starting from left. -6 plus 3. This case is case 3, so we can write this as 3 minus 6. 3 minus 6 equals -3. I have a video on subtracting integers if you want to watch it, link in the description. Moving on, let's bring down -4. -3 plus -4. This is case 4. Two negative integers, so we add 3 plus 4 equals 7, and we copy the negative sign, so the answer is -7. Now you learn about adding two positive integer, adding integer where the second number is negative, adding integer where the first number is negative, adding two negative integer, and lastly adding multiple integers.